For those of you who don't know or have never used one, this is an analog multimeter, commonly just referred to as a voltmeter. It's a very inexpensive tool to keep around your house. I paid about $10 for this particular one, but honestly I've seen them in dollar stores these days for about $2 or $3. And really they all do the same thing. Today I'm going to show you how exactly this works and a couple applications around your house where you could use one to diagnose a few problems that you may have. To use your voltmeter, you'll have a set of included wires or leads to go with it. The black wire connects to the negative side of your terminals, and your red wire connects to the positive side of your terminals. And they are labeled, but really just think about a car battery. Red is always positive on a car battery. This voltmeter will do a lot more than what I'll show you here today, but to keep things simple, I'm just going to show you DC voltage, ohms or resistance, and AC voltage. The purpose of the ohms or resistance meter is to determine whether or not there is a closed path or circuit for electricity to flow through. If I was to take these two leads and push them together and the meter goes to 0, that means that there is 0 resistance and there's a closed path for electricity to flow through. You can take that basic knowledge and use it to diagnose a lot of different circuits in your house. Simple circuits such as an extension cord. You can verify that from one end of the extension cord to the other end with 0 on the scale. Have a full path, a closed path from one end to the other, and this particular wire is not faulty and it works just fine. Let's just say that this is an extension cord and every time you plug it into the wall to use it, it trips the breaker immediately. And you're trying to figure out what exactly is going on. Well, if you take one end of the extension cord and you start testing different combinations, you might be able to find that two particular wires are shorted out. Somewhere along the path, two wires have shorted out, and that means this extension cord is no longer good or needs to be repaired. You can use that same concept to test all kinds of stuff around your house. For example, this light bulb. If I connect one side over here and then one at the bottom, the meter tells me that there is a continuous path through the light bulb, meaning this light bulb is good. Now let's change from ohms to DC voltage. A good example of where DC voltage is used is in batteries. Now both the DC voltage and AC voltage have different volt settings on here, different maximum voltage settings, and this is a maximum number. You don't want to exceed this. So if I'm using an 18 volt battery, I don't want to go down to 10 because I'm exceeding the voltage on this particular meter and it could cause harm to the voltmeter. You always want to go to the next highest setting. So on this one, the next highest from 10 is 50, which is where I'll test this 18 volt battery. On DC voltage, the red wire is connected to the positive and then the black wire is connected to the negative. So it's important that you do connect these in the same series on your battery. And as you can see here, this is an 18 volt battery and that reads 18 volts. Now this could get a little confusing with all the different numbers in here, but the way that this works is if I've set to DC 50 volts max, then according to this voltmeter, the black lines in the middle, the black numbers, represent both AC and DC voltage. So I'd go to the maximum number, which is 50. That means the interior line, or this interior arc, is where my reading will take place. So again, if I put it on the battery, that interior middle line is two notches shy of 20, which means that this 18 volt battery is reading at 18 volts. To go from testing DC voltage batteries to the circuits in our house, we need to go to AC voltage. Now typically the two circuits that we have are commonly referred to as 110 and 220 volt circuits, but technically speaking it's a 120 volt circuit and a 240 volt circuit. So to go to the next highest number is 250 on this AC voltage scale. This is a common 120 volt receptacle and you can test it by putting the leads right into the slots of the receptacle and the meter will show 120 volts of electricity. This is a good way to show you if this particular outlet is powered or not. Let's say you're working inside one of these electrical boxes and there's a set of exposed wires, and before you actually work with those wires you need to verify that there's no electricity going to them so you obviously don't get electrocuted. The way you test exposed wires, and I'm using this wire that I used earlier for an example again, is with your AC set to the correct voltage setting, attach one of your leads to the white wire and the other lead to the black wire. And if you're not getting any voltage on your reading, then that tells you that this particular set of wires has no voltage going to the circuit, and it is safe for you to work with these wires as needed. So what I've shown you today is just barely scratching the surface at how incredibly useful one of these tools can be. There's a lot of problems that you can diagnose around your house with one of these very inexpensive analog multimeters or a voltmeter. If you have any tips, tricks, suggestions, or areas around the house where you found one of these multimeters to be incredibly useful, please leave it in the comment section below. Doing so will greatly help out the next person who may encounter the exact same problem that you once had. I do have a couple videos planned to use one of these voltmeters to diagnose a couple appliances around the house, so if you haven't already subscribed, go ahead and subscribe to Home and Garden for Mere Mortals so you don't miss any of those upcoming videos. Thanks for watching, folks, and I'll see you on the next project.